right, we are back at AP Review. This is 2015 BC Free Response 2. It is a calculator problem. So at time t greater than or equal to 0, a particle moving along a curve in the xy plane has position x of t comma y of t with a velocity vector here, right? At t equals 1, the position of the particle is 3 comma 5. Cool. All right. So the first thing I did is I went into parametric mode and I put in, so what I did is I put in my velocity as my x1t, y1t, okay? So I'm going to make a note to myself, okay, cool, this is x1t, y1t, right? It's the velocity, not the position. So you don't have to do that, but I think certainly some of these problems do confusing things, like they give you velocity in one direction but position for the other. So it's worth noting what you put in as what. So part A, find the x-coordinate of the position of the particle at time t equals 2. Okay, so this is a first fundamental theorem of calculus question. So it's worth noting that essentially my x prime of t is the cosine of t squared, and my y prime of t is the e to the 0.5t, right? So I know that x prime of t is cosine of t squared, right? That's what it is. So if I were to integrate x prime of t with respect to t, I know the position at 1, and I want the position at 2. So if I integrate from 1 to 2, I would get x of 2, which is the quantity I want, minus x of 1, which is a value that was given, right? And this is a thing that I can make my calculator do. So in order to find x of 2, right, what I want to do is I want to write x of 1, which is a 3, right? 3 plus the integral from 1 to 2 of cosine of t squared dt. And then I let my calculator do the work. So I'm going to quit out of this, right? So second mode. I'm going to do math 9, right? I'm going to go to vars, go over to yvars and pick parametric and pick x1 with respect to t from 1 to 2, right? And then I'm going to add to that a 3 after everything's done, right? And I get 2.556, right, or 2.557. So I get that this value is approximately 2.556 or 7, and there were no units in this problem, so I don't invent them. All right, part B rather. For values from 0 to 1 of t, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? Okay, so what they want me to do in this one is set the tangent slope equal to 2, and then solve, right? So if we think about what this tangent slope is, right? So in part B, right, remember that tangent slope is dy dx equals 2 in this case, right? But in order to find dy dx, right, we need to remember that in parametric, dy dx is the same as dy dt over dx dt, right? Well, in this case, that's the same as e to the 0.5t, sorry, I threw a random decimal after the e, over the cosine of t squared. So I want to set this equal to a 2. Now that's nice enough and not awful, except if you look at your parametric mode, it doesn't allow you to do it, which is just the worst. So that's no fun at all. So unfortunately, since there's no second calc intersect, right? There's no second calc intersect, which I think a lot of us have come to rely on, in parametric or polar. And that's sad, right? So what I would probably do is I would probably switch back to function mode, and in my y1, I would type this entire mess, right? I would type e caret 0.5t, right? Close those parentheses, although I don't really need to, divided by a cosine of it wouldn't be a t in function mode, right? It would be an x divided by cosine of an x squared, right? And then I'd make my y2 a 2, and then I'd second calc intersect. So the bummer of this part B is not, so this is what the AP needs to communicate. The AP needs to see this, right? And then they need to see you skip to the end where you give them a t value. The tricky part here is that there's just, if you do second calc, you'll notice that in parametric mode and also in polar, there is no second calc intersect. I'm going to quit out of this. I'm going to go back to my mode, and I'm going to jump right back to function, right? I'm going to go to my y equals, and I'm going to put in my e to the 0.5x divided by cosine of x squared. And it really isn't that awful. And I put a 2 into my next one. And I know it's the window between 0 and 1, so I'm just going to be really lazy. Conveniently, my window already went from 0 to 3, so actually it's not awful, and I'm just going to go ahead and hit graph. So if I didn't have a convenient window already, then it would be an issue. But it's going to come through right around here, right? You're going to see it come in right over here. So that's the point of intersection that I want. So I'm going to do second calc intersect. Now I'm over down on this piece of the curve, so I've got to work my way backwards past that asymptote. And there it is. Close enough. Enter, enter, enter. And I get that x, which is my t in this case, is approximately a 0.840. So I get that my t is approximately 0.840. So again, it's not actually the calc that was hard there. The AP wants to see you set up this equivalency, and then they just don't give you the mechanics easily to find it. They don't care what this looks like, but you need to know how to find it. Let's see. Before I move on, I'm scanning quickly to make sure that they don't ask me to use that time again. If they did, right, if you had to use this again, you could quit out, and it's currently stored as an X, and then you could store the number. They don't ask you to use it again, so I don't have to worry about it, but you should always check that, because it's a real bummer when you have to go back and recalculate something you already had because you didn't store it and you had to use it. So I didn't need it. Cool. Part C. Find the time at which the speed of the particle is 3. Okay, so for this, you want to know when the speed is equal to 3. So you need an equation for speed, and then you're going to use second calc intersect again. What the AP needs to see is that you know the equation for speed. So the speed of a particle is x prime of t quantity squared plus y prime of t quantity squared, all inside a square root. So you want to know when this thing is 3, right? So to get your credit on the AP, you need to put that you're putting cosine of t squared quantity squared plus e to the 0.5t quantity squared equal to 3. The AP needs to see this, and then they need to see the answer, right? They need to see that value. And that's it, right? That's what they need. But the mechanics of how you're actually going to find that, you're going to be happy that you're in function mode. Because I'm going to go ahead and change my y1 to this ugly monstrosity, right? Cosine of t squared plus e to the 0.5t squared, right? Close that whole thing. And I'm going to make my y2 a 3. And I'm sort of curious, so I want to try something real quick. Remember that we already had these functions in my parametric mode. So I want to try a thing, and it may not work, but hey, why not try it? I'm going to see if I can use the vars to actually see if it'll let me use the cosine and the e function if I use x1t and y1t. I don't know if it will, because function mode is in terms of x and these are in terms of t. I have no idea if this is going to work, so since I don't know if it's going to work, we're just going to try it and see what happens. So x1t squared plus vars over, and it really might not work. Again, this is totally just a guess. Checking it out. Let's see if it graphs it for me. It may or may not. It looks to have only graphed the second one, so that didn't work, but it was worth trying. So let's go back to our y equals. So I'm going to put my square root of cosine. It makes sense that it didn't work, but gotta try. So I've got my cosine of x squared quantity squared plus my e to the 0.5x quantity squared, close the square root. All right, so I quit out of that. I graph again. Now hopefully and there, this time we see it, right? So it definitely just didn't work last time, which is fine. It doesn't hurt to check, right? Every once in a while, you stumble upon a shortcut that actually works and saves you a ton of time. So that's the point I want to second calc intersect, right? So I stayed in function mode. I second calc intersect. Some of the tricks that we've learned in our math classes over the years really only work in function mode, which is fine. You just have to adjust accordingly. Remember that in function mode, you're using x to represent the t. So the point of intersection that I get is 2.195 or 196. And again, it's an x here, right? But it's a t in the problem. So 2.195 or 6, right? So the AP cares about this and this. That's what they want to see, right? They want to know that you know the definition for speed, and they want to know the answer. Part D, find the total distance traveled by the particle from 0 to 1. So the thing about total distance is just integrating speed. So if you were already in function mode, right? So when you go to do D, right? When you go to do D, what they need to see is that you know what total distance is. So total distance is going to be if you integrate the speed, right? So you want to integrate, they said total distance from 0 to 1. So from 0 to 1 of the square root of cosine of t squared plus e to the 0.5t quantity squared with respect to t. That's the definition. They need to see this definition, right? They need to see that you know the definition. They did not call this x prime of t and y prime of t, which is why I have not been calling them x prime and y prime. You have to use the notation that you're given. So I wrote the entire function because they did not call this x prime of t. And then I'm going to go ahead and integrate. Now, but keep in mind, because in my calculator, I already stored this whole thing as y1 just a second ago, all I have to do is do function integrate, right? All I have to do is do function integrate y1 with respect to x from 0 to 1, because I'd already set the speed as my y1 anyway. So if you go back to my y equals, there's my y equals. I'm going to quit out. I'm going to do math 9, right? Math 9. I'm going to pick vars over to y vars function y1, comma, with respect to x from 0 to 1. And that's going to do it for me, hopefully. And we get a right answer. So that's what we need. 1.594 or 5, depending on whether you round or truncate. And again, the AP is not going to care about this, but you need to be able to do it. So, cool.